Hello and welcome back to the channel. So in this video let's do a mixed example when you have to basically convert a Riemann sum into a definite integral. So you have this sigma notation and you have this function. So in these type of questions you are given a sigma notation and you are given a definite integral as well, and based on all the given information in the question you have to find the function f of x. Please don't get intimidated by the sigma notation, because if you know how to follow the steps that we discussed in the previous video on converting a Riemann sum and extracting the function out of a Riemann sum, this question will be very easy for you as well. You will have to basically follow the same approach that you used in order to solve the questions that we discussed in the previous videos. So if you have not watched my previous video and don't know what steps I'm talking about, I would highly suggest you to first watch that video, which can also be found on the I button above. I would highly suggest you to first watch that video in order to get the full context of this video. So we'll start with solving this question with the same approach. So based on the question, we'll first write whatever it's given to us. So now I see that I have a function, a definite integral, which varies from 0 to 1. So based on this, I can easily extract my endpoints. So my left endpoint, which is denoted by a, is 0. My right endpoint, which is denoted by b, is 1. Because my definite integral is going from 0 to 1. So based on this, I got my endpoints. And I also know that my delta x is equal to b minus a over n. In this case, b is 1, a is 0. So my delta x is 1 over n. Okay. So now I'll solve for my xk. I'll write xk in this example because they have used k in this sigma notation, but we have also covered the same concept using xi. So I'll start with xk. My basic notation for xk is a plus k delta x, right? In this case, my a is 0, my k is k, and my delta x is 1 over n. So my expression for xk would become k by n. And now I basically have to replace every occurrence of k by n and substitute x in place of k by n. And when I'll substitute every occurrence of k by n and change it to x, I'll get my final function. So now let's simplify this expression and substitute k by n as x. So I'll write the expression again. So my expression is k by n square times 1 minus k square by n square. So now I know that I want k by n, so that I can change every occurrence of k by n as x. So I'll simplify this down. I can write k by n square as 1 by n times k by n, right? And I can write the square root expression as square root 1 minus k by n whole square. And now since I have to replace every occurrence of my k by n as x in order to get to the final function, and I also know that my 1 by n is delta x, because delta x is 1 by n. So based on everything what's given, I'll write the answer, which would be delta x times k by n would be changed to x, 1 minus k by n square would be changed to x square. And this is my answer, this is my final function. So my fx in this case is x times under root 1 minus x square. And that's it, the question is solved. So that was it for today's video. I hope following these steps make your calculations much easier, and based on this you can calculate any function. So I'll wrap up this video. Please follow the channel in order to get notified about the other videos that I'll be uploading. Stay tuned for more updates. Thank you so much for watching. Bye bye.